This video will cover the reaction of alcohols with thionyl chloride. Thionyl chloride has the molecular formula SOCl2. Synthetic chemists often abbreviate this molecular formula by calling it SOCl. The structure of SOCl2, thionyl chloride, looks like this, and it is the preferred method to convert an alcohol to an alkyl chloride. If we treat this alcohol with thionyl chloride and heat, we again see a single stereoisomeric product of the alkyl chloride. Unlike previous methods that we've looked at, though, what we see is retention of stereochemistry. When we look at the mechanism, it will become more clear why this occurs. The other products of this reaction are not organic, but are useful because they help to force the equilibrium to the right, because they're both gases and therefore escape the reaction mixture, preventing the reaction from going backwards. Sulfur dioxide and hydrochloric acid are both formed and are lost from the reaction mixture, preventing the equilibrium from shifting back towards the reactants. Now let's look at the mechanism of this reaction. In the first step, the alcohol attacks the good electrophile of thionyl chloride. This forms the equivalent of a tetrahedral intermediate in the attack of nucleophiles on a carbonyl carbon. In the next step, the sulfur-oxygen double bond reforms, kicking off a chloride ion. Next, the alcohol is deprotonated to remove its formal charge. What we have done up to this point in the reaction mechanism is to turn the hydroxyl group from a bad leaving group into a very good leaving group that would be resonance stabilized upon leaving. The next step, then, is that the leaving group leaves. Before the leaving group has time to significantly move away from the carbocation that is formed, it delivers the chloride ion. Because this happens so rapidly following formation of the carbocation, the chloride is typically delivered to the same side of the carbocation that the leaving group has left on. What this means is that there is no inversion of stereochemistry possible, and we always get retention of stereochemistry when we use thionyl chloride to convert an alcohol to a chloride. This mechanism is followed if the alcohol is secondary or tertiary. If we have a primary alcohol, however, we cannot form a carbocation, so the mechanism looks slightly different. In primary alcohols, the first half of the mechanism proceeds similarly as the one we just looked at. The first step is attack of the alcohol on the thionyl chloride, then reformation of the carbonyl to click off the chloride, and finally deprotonation of the alcohol to produce the neutral intermediate. It is at this point where the mechanism changes. Instead of formation of the carbocation followed by attack of chloride, it is concerted in the primary alcohol mechanism. Again, because the leaving group leaves and the chloride is delivered from the same side of the molecule, we again see retention of stereochemistry.